All right, welcome everyone on the Multi-Network Community Sync. Today is May 31st, and today's on the agenda. I would like to continue the. Oh, someone removed the agenda for us. Yes. No. Okay. Something happened with the file. Where was this? Oh, there it is. Okay, I'm back. So I want to continue and finalize the discussion about DRA usage, and then if time permits, just continue on the CAP discussion. So I'm not sure we have anyone. Yeah, Patrick is here. I had some thoughts about the DRA, and let's discuss. And I want to know kind of what you think or what I'm going to want to say. So, from what I understand, DRA is basically, I don't want to diminish it in any ways, but it is an enhancement to the scheduling process of the pods, because I want to request in a special way some stuff, and that kind of helps with the scheduler. So it boils down to it kind of helping with the enhancing the scheduling process itself, and basically kind of reusing the capabilities of specifying the resources in the pod, but basically it all translates to having a scheduler, enhancements, and having a plugin that can externally do something about the schedule. Can we agree on that, or is there more to it than what I'm saying?
I think there's more to it than that. Patrick's going to be able to tell you more detail, but DRA gives you APIs that mean that when the pod is actually instantiated, there are callouts to do various things. And
no, those are enhancements to how I select and how much of a resource I select, right, Pete?
Well, it's two parts. It's the scheduling part that ensures that your pod actually gets scheduled to a node where resources are available. But there's also the kubelet part, and the kubelet part takes care of setting up your containers. So it's both.
Okay, I missed that part. You're right. So there is the kubelet side but what's there? Is there an additional to what kubelet can do today? What does that mean, what you're saying, Patrick?
There is currently a mechanism for enabling container device interface descriptions or injecting those into the container runtime. And container device interface itself is a fairly flexible extension mechanism for container runtimes that support almost anything that you could imagine, with adding device nodes, mounting volumes, setting environment variables. And all of that can be done, and all of that is under control of the hardware vendor. So there's no need for someone to modify a container runtime to do something special for certain hardware, as long as it's using these primitives.
So to the second part, what I would look at it as one of the implementation ways for multi-networking. I'm not sure, Patrick, you had a chance to read through our CAP that we are writing currently or through the requirements, but we are trying to create multiple ways to how you can implement the multi-networking. We have existing multus, we have Google builds, we have our own stuff that we are building for multi-networking support. If I were to use DRA and we would integrate fully with it, like what you're thinking, that would hinder that, because now that we are enforcing, you have to implement it through DRA, end of the story, nothing else.
So I don't think that's the right way to think about this. So in my mind, we have a multi-network proposal, and we have DRA, and they're independent things, but we want them ideally to be for it to be possible to use the two together. Now, for the most part, they don't need to know about each other, in that you could be using DRA to get SRIOV devices or something like that, and it isn't necessary for the the stuff that we're talking about in these meetings to be engaged with that at all. So I think
how would you
probably.
No, that's probably true, because I don't want to, my first maybe kind of tone maybe what was about this thing, but not that, because I'm trying to kind of address the other part of the array, the kubelet side. But I will step back to the scheduler side first then. What I'm saying, it's an enhancement of how a schedule can be done, which I do like. And basically, as you, Patrick, last week you said you would have to anyway change how, for example, you do stuff for the pods, because our stuff has to be on a pod level, not on a container level. Considering you already have to change that part and then adjust application of this, why even bother with that? Why not just use what we initially create with our APIs? What I'm saying here is the scheduler part. I do agree that let's reuse the scheduler part for our implementation as well for multi-networking. But what I'm trying to kind of get to is the scheduling part that we, at least that part. And I understand there is the kubelet side, which we can kind of talk in a second. But the scheduling part of the whole thing, this is something that we definitely want to touch in multi-networking. But I don't see, and this is something that on our requirements list is it is on the second phase. If you look at our requirements list, there is a second phase in which we have a requirements which says, let me maybe, no, that's not it. Which says, where is it? Let me just recall, I had somewhere here. Pod network can be selectively per node available in the cluster. So basically then we need to tweak with the scheduler and what's not. So what if at that phase, when we're gonna try to address this requirement, look at the array, so instead of us re-implementing the whole thing and adding new paths in the scheduler, just reuse the array, but the array can work off of the APIs that we come up with. All right, at least for the scheduler side, for the pod side. Then is the underhood, the kubelet side, on how we are going to deal with the additional thing. And even with what you're saying, that it can live kind of beside, that's something that we need to kind of think about, right? Because can that really be true, right? Today, if let's call out, for example, how SROV is done today with Multus and with the resources, and the SROV operator today is that there is the SROV operator, which is completely independent, and it will prepare your resources. So it will create the numbers of VFs you have available on each of the nodes, right? And then there is Multus, which is completely independent, and will just point out to the specific device resource. So basically you have two separate components that one prepares the resource and the other just leverage them, whether they are there or not. Here, the array is all integrated, right? Because you can, with a scheduler, okay, you can list the resources, because I can query the controller and it can tell me who has what. But then, Patrick, you're saying there's a kubelet side, which then can do additional stuff. And I assume those are not disconnected today, like Multus and the devices, the device resources, right? And they come in pair because there might be some additional configuration required for that special device. Otherwise, I would just use the standard device plugin, right? So you see, Pete, I'm not sure whether, so that's something that we have to discuss, whether we can disconnect them somehow or not but then if we cannot disconnect them, that can lead us to the case what I was saying initially, where we are stuck with it, and that's the only way you can implement these things. And which something that I definitely would not want to go, or unless I'm missing something, and please correct me if I'm missing something, or maybe there are some other changes we can do here to kind of address. Alexander?
So I just wanted to say there is some, I don't know, like misconception or misunderstanding how the array is working. So like, yes, the kubelet and controller part of the array were connected, but the kubelet part is also connected to low-level things like to runtime, to pass the information.
Mhm.
So the whole idea behind the DRA is to avoid all kind of like out-of-band or backdoor communication about like resources. So practically, like we think what you are currently doing in Multus by analyzing the annotations and then from those annotations connecting to the API server and then fetching the rest of the configuration and so on and so forth. For me, it sounds as a not really good architectural decision. So like low-level component is calling to the upper layers to fetch the information. So the main point of the kubelet part of DRA driver is to actually prepare all the needed configuration from the high-level objects like CRs or whatever else, store it locally on the host, and then pass it down to runtime where these configuration parameters can be used. So it's not a matter of disconnecting the like DRA part. It's more about the question, like what actually information you need for the network. So we can pass it properly through the kubelet, through the CRI, to the runtime, and then to the CNI plugins to actually, for you to easily to consume it.
And Alexander, understand this, like Multus is going, I know if you think about Multus, that was like 2 years ago and 1 year ago, that's true. Today, Multus is what they call it a ticked CNI. And this is something that like most of the implementation does that. What it means is the CNI piece is just a stub, is just a simple binary that just does gRPC call. And that's it. And it does the gRPC call to a daemon running on the node, which has a full access to API and has a full plethora of needs to do, and query the API to do its bidding. And then finally, at the very end, it will just go to the yeah, Tomo, maybe gRPC maybe it's done, but basically it does a socket call or what's not to the, depending on who's implementing. I think I'm in Google we use Cilium. I think they do gRPC if I'm not mistaken. But what I'm saying is that understanding that CNI is just a very low level thing, it's not true, because it's just that small thing that's being called, and then it calls a big agent that has the full knowledge about everything, can do all the proper like a controller operations, because it has to, and because that's the implementation, Alexander. And I'm not saying
Well,
it's but and basically what I'm getting at is that's one of the implementation, and there can be the case where what you're saying, where yes, I don't want to have a implementation just gonna get a pass down parameters and do its binary without any API calls, without network, without any other networking calls from that binary. It will just do and be contained within the node, and that's it. And that's another implementation that's valid. What I'm saying is we cannot lock ourselves in one and force everyone on one approach. That's what I'm trying to push back on. If DRA, and basically now when you were saying that DRA passes parameters, and that might be useful, maybe that's something that then we can leverage as well. And maybe that's something that instead of us doing some additional passing of the and creating another path of passing wherever pod networks we selected into the CRI, we can leverage the array. I'm not saying that that cannot happen, because we can in the pod we will specify our stuff the way we want to, and then through the array we can pass it up to the kubelet and then CNI, right, and CRI. And then along the path, along the road, if someone has a need to implement more and leverage more of the array, where maybe some of the QoS stuff can come into play, and that's fine, then can reuse that and leverage that. But otherwise, maybe they just care about just passing the parameters into the CNI, and then the other side agent does the whole thing. So maybe we are not talking here about implementation of that part, at least, because right now I don't think we are there yet. Maybe there's something that we can touch on right now as well. But in terms of like straightforward API, this is something that I said last week, right? That we do have to have the API definition. I don't want to, because I see DRA as a specific solution for a resource handling and then passing stuff to container. That's perfectly fine, but it doesn't fulfill all the requirements that we have for multi-networking. That's my problem with it. And I would not want to just hammer down DRA into this instead of the whole multi-networking APIs, just because it's convenient currently, because it has some of the major things in place, which I think we have to have something that's fully fit the whole requirements that we are trying to kind of discuss here now. And I agree to leverage things, right? Because then when we're gonna go to the scheduler, and then when we talk about passing things through to the CNI, I agree. Then we can just leverage the array paths so that we don't have to create our own. Does that sound reasonable?
I don't think
agree.
anyone. Just 1 second, Maciej, have you seen Peter White's document?
Don't think so. No, I don't think I had a chance.
Because he is showing example YAML files where there is a custom API for the thing that you seem to want, and in addition, for some things it's using DRA. To me, that looked like a good compromise where you do have custom network APIs that do something that goes beyond what DRA handles, but it also leverages DRA. That particular proposal made a lot of sense to me.
I don't think.
So I put a link to it in the Slack channel. So
now I see. Let me maybe just.
So
I didn't have a chance.
Sure, let me give you a kind of 30-second summary of it. Sometimes, so DRA in my mind it's a bit of a sledgehammer to crack a nut sometimes, and sometimes it's exactly what you want. It's got a lot of capabilities in both scheduling and in terms of device management, and they're very tightly tied together in ways that close a lot of the awkward cases, such as you schedule a pod and, oh look, the resource has been stolen by something else before you got there, that kind of stuff. So it's quite it's very useful for certain use cases, but it is also probably too much for many of the use cases we have, the simpler use cases we have. So what I was thinking about was, well, could we use DRA, and what would that actually involve? And almost all it would involve is some kind of link from the pod attachment to say, and this is my DRA device, and let the implementation worry about setting everything up. And I don't know if that's the right approach, but it felt like something along those lines might make sense to do something like that. I certainly think the thing that in my mind is missing so far is we haven't talked about, if I have a pod network attachment, how do I get parameters? And that might reference DRA, it might reference something completely different. What could that possibly look like in the attachment to say, this thing here has got to have this clause, or this DRA device, or whatever it might be, this DRA resource claim.
So this is something that we are, I think, in our discussion for the CAP itself, we kind of I touched on, but I think we didn't expand on it. This is what's kind of missing when you say resources. So I'm trying to the last part you mentioned. So where would that be? What would that fill that role of identifying what sort of parameters for the pods I want for a specific attachment?
So the way that I suggest it, I don't think this is necessarily the right way, but if you keep going down to where it says pods, you'll see the link there. So you have a pod, DRA tells it what devices it'll be attached to, and I've said the example I made up is an FPGA and some network device. And then you have something in the pod networks that says, okay, for this one, for this pod network, there would need to be some kind of linked claim that says this is the DRA that this is using. I don't think that's quite right. I think probably we need something more generic than DRA, but we'd have the option for a pod network to say, and this is the thing that you need to, that the implementation needs to look up to find more about how this is going to be attached to the network. And I don't know, DRA clause, maybe just some custom resource, whatever it might be for that connection.
One thing which I want to repeat is what like DRA is a big hammer, and we probably don't want to use it for all the scenarios. So like the DRA is good if you want to attach multiple network interfaces and with different parameters. But if you have like part of your CAP where you are talking about, like, let's say, like which one is the default network selection, like out of several variants, we can do something more simpler. Like we can leverage the concept of QoS classes to select like blue network from red network as a default pod network. And that will be like easier for user experience, easy for scheduler, easy for everyone.
So this is where I'm getting as well, Alexander. What you're saying, you're trying to, this is something that I don't like, where we are trying to, let's bend somehow the DRA to fit what we have here in multi-networking. That's something that I don't like, because you want to kind of hammer it down to the form of what we want to do. Not
exactly. Not exactly. Let me like try to open up a bit, like overall thing. So our team, like we are working on several things, and like DRA, QoS is part of those. We have also thing which is called NRI, Node Resource Interface, like the plugin on the runtime side, so we can affect how the containers are created and how the pods are created. And networking part, like with CNI processing, is also something what we are looking at. But all of those features we are targeting to one big well, we can say it like epic story or something like that. So under one umbrella, we think what I'm trying to do with my team is what we want to improve the whole communication between the like kubelet, between the runtime, between all kind of plugins, like remove all this legacy what Kubernetes accumulated because of the Docker as a runtime, like Docker shim legacies, like VC groups management, like imperative interface over VCRI, using like backdoors like pod resource API what Cilium using to fetch some of information of kubelet. So our overall goal is to make sure what our CRI APIs, where communication between components is good enough, so we don't need to create a new workaround to pass the information. So it's not really bending DRA to the network. It's more about we are trying to define what it means pod level resources. Is it something what will be just like needs to be injected to a container, or it needs to be injected into the namespaces of the pod itself, like network or PID or mount or whatever? The same applies to like information passed between the components. So what we like when we are telling to the runtime, let's create a pod, what like who is responsible for doing like C groups management or like namespaces setup or something. Right now there is a like split brain between kubelet and runtimes for that. And that creates like bunch of problems, like huge page handling, like in place vertical pod after scaling, like all the implicit communication, what is happening for CNI, like image pooling for confidential VMs and so on. So like there are a bunch of problems in those protocols, and we're trying like piece by piece handle that to shape it like how the CRI, how these interfaces will be looking in the next like few years. So that's our story.
So that's kind of fits to what I was saying. Can we not just then leverage the array to pass all the parameters through the array? That should be fine, or it won't fit, it won't kind of work. If I were to have this piece define I want this networks, right? Next element would be to leverage the array to identify which nodes are available for those networks. That's one part to kind of answer the question on the scheduler where a specific network is there. And then in kubelet, we leverage the array to pass any and all informations about the specific networks, right? Whatever we need to pass, and based on the array. And then when I think of controller for the schedule, this is something that will be part of we would have to create for KK, and I'm talking that will be part of the core where we would create our own. Probably you can call it a reference implementation of the resource controller, which will be very simple to kind of answer a question whether a specific network is there or not on a specific node. And it will implement just a basic thing to kind of fit into the requirements for the array. The array code as well in a scheduler would understand this piece because it will look either on the resource claims or the pod networks for the pods. So it will understand those this and that, and then for the other ones it will query, it will know, okay, for pod network I query this built-in resources or this endpoint, which we can then make it pluggable. Someone wants to create their own, they have a template how to do it, they can create their own with more sophisticated stuff if they want to. So there is that capability later on. And then lastly, that's where kind of what I'm missing, how, because I'm not sure that the CRI part, how would that fit in? This is something that where I'm kind of missing on that part.
So
how we would do.
I can try to explain.
Mm-hmm.
So like imagine like you are trying to request one network interface like VF, which is attached to particular like VLAN, right?
Mm-hmm.
And imagine what this VLAN port is not pre-configured. So it's not enough for you to just create VVF. You need to also like do something to configure the switch. So this VLAN will be available to this physical interface and then obviously to this VF. So the whole idea of DRA node part, like which is talking with kubelet, is actually to do all these preparation steps on the node, what is needed. So
right.
like so when the pod arrives to yeah, you have scheduling piece, like let's forget about it. So the pod arrives to the node, and kubelet calls your vendor code, like vendor part of the array, saying like, okay, I got a pod. This pod is going to use this particular claim. Do whatever is needed to prepare everything. And at that time, your like DRA driver part is responsible to do all the needed preparation. So for example, like set up VF, call to network infrastructure saying like, okay, on this switch port, on this physical port, provision me, or give me access to VLAN XYZ. So
that's
all
fine,
of this
Alexander.
Let me finish.
No, so because you're going into the very extensive use case. Please go to the least extensive
I understand.
use case.
I understand, but let me finish. So at this point, so as soon as the resource is prepared, where the driver part needs to return something. And in case of devices, how we are using, we're just returning with unique ID, how to reference the local information about this device. So this ID is passed down to like runtime, where it expanded to what is injected into container time. The same thing applies to your part, like example what you gave like previously with Multus. So Multus will get as a parameter from runtime with string ID saying like, well, this pod is requesting this particular ID. And Multus can reach out to this daemon, what you mentioned, to actually get the rest of the information about this ID. So CRI in that sense is quite simple. So it doesn't expose all the parameters. It's just a way of communicating where unique set of parameters which is used between the components.
So, okay, so correct me if I'm wrong here, if I understand right. What the scheduler, okay, and pod arrives to the node. Let's start from this point. There is a additional, what I'm hearing is there is an additional pluggability capability that I can introduce per each network if I want to before the request arrives to CNI.
Yes.
Is that
So,
correct
yes.
statement?
Yes. So if you know the storage, so like you have a like CSI plugin, which prepares like mounts the remote device, mounts it to a particular directory. And when the kubelets just say like container, you are going to use the directory, like volume, which is already mounted to this directory. For DRA concept is really similar. So like kubelet says, I got a pod. This pod is going to use that resource. I don't know anything about resource. Hey, vendor code, please do whatever is needed to prepare that resource. When this vendor plugin just replies, okay, I prepare it, or no, I'm not able to prepare it for some reason. And it gives like ticket. And this ticket is passed down the stack, so this ticket can be used to fetch the additional parameter. So,
Okay,
like in your example, this Multus daemon part, what you mentioned, it can act as DRA node driver part.
Right. So basically, so no, that's I think that then fits, right? If we look at it in that way, that can be an optional enhancement where before you even run into your CNI, because your plugin, right, can basically, if I want to, and I be kind of, maybe not, depending on how far it's not integrated on this level, because I have now two places where I can do something on my own, right? Two. So I have the DRA plugin, and then I have the CNI itself, right? If I were to be stubborn, I can just do the whole thing in the plugin and be done with it, right? The problem is the plugin doesn't return, and basically kubelet doesn't understand what the plugin returns. Is very minimal.
Big difference is part of a life cycle. So DRA kubelet part, DRA kubelet part, it's before anything is happening. So before anything is even passed to runtime. So CNI call happens when the pod is created, but none of the containers get created.
Yeah, I hear you. That's fair. Yeah, you're right. You're right. So basically, it's very okay. I hear you. But basically, that expands our multi-network capability with additional prepare, if you want to, on before even the pod is being started. Yeah, that's I see that as a win. But question to you, Alexander and Patrick, are you okay with what I said? Like, we will leverage still our APIs, and then the array would adjust to and use those. Like this piece here, I like this piece here, like what Pete kind of proposed here. I don't like a user having to specify both of those things. I would say user specifies pod networks and this section, and DRA understands that and then leverages later on in some ways. This part is for the strictly just the DRA. If you want to do DRA, something completely unrelated to multi-networking, yes, go ahead and schedule those for your own sake, whatever you want to pass in. But basically, our core API to use, what I'm saying is just this.
So I think what you're saying is you'd like the resource claims, if it's related to networking, to go into that pod networks field.
I would say I should not even need those. DRA should understand this. What I'm saying.
So DRA needs to. Sorry, go on, Alexander.
Sorry, I might be not understanding like properly. Well, let me say it that way. I haven't read the document, so repeat. I saw it, but I haven't read it, so I don't know about examples. But the main thing about the DRA, like as overall concept, the scheduling part and the pod spec modifications, it's really minimal to give the maximum flexibility to the vendors. So the whole idea of like separating the claim object with parameters is to give the full flexibility to the vendor. So meaning what, like Cilium can have their own set of parameters, like I don't know, like Viv network something else, reference plugin something else. So
Okay.
looking at what I'm seeing on the screen under this like pod networks part of the object, I don't know what kind of controller will be consuming that. So in mind, Patrick, correct me if I'm wrong. Like, yeah, it's possible probably to write a controller which will be converting it to some predefined template of a claim. But how user-friendly it will be, I don't know. We need to see, and we need to play with examples, how the pod spec look like.
Maybe let me share this. What I don't like with the, I think Pete's example has indentions, not the way I want it. Because my core element in this whole thing is that pod network attachment is on a level of containers. There's something that Patrick caught up last week as well, where you would have to change your APIs, understanding of your APIs, to have those on a on a pod level, not a container level, because we don't care about container level stuff.
That's correct. Like like when we are talking about using DRA for network bits, obviously it will be pod level, because the pod network namespace is one per whole pod.
So this is what I'm getting at, is if we are to change that, why can we not just directly use those guys, this type of API? That's where I am trying to say that then your DRA would understand the pod network attachment list. That's what I'm getting at. And this is that acceptable for your, that under the hood somewhere there, unless you want to tell me that that was your plan anyway, to have a pod level resources.
Our plan was to have pod level resources, but they would be using the DRA API. It was not the goal to have core APIs that are defined completely or completely hide DRA. That has not been part of our plans. I'm not sure whether it would be a good design.
So let me say it that way. What we are trying to do, we are not trying to introduce the new scenarios like it was done for the storage, where like all the parameters for the objects are hard-coded in the core API. Yeah. We don't want that.
Sure, yeah.
So to phrase that differently, DRA will go GA without implementing anything related specifically to pod network attachments. That would be an add-on that could leverage a DRA, but it would be a separate cap describing how that works and how the new API gets mapped to existing map mechanisms in DRA.
I agree. My question for you would be whether you would agree for us to do that. That's
so
my
can
question.
I check what we're proposing? Is it just to put the resource claims into the pod network attachments? So the existing resource claims, just as DRA defines them, they could now optionally go into pod network attachment if they were related to networking.
We can do what the claim will be in the pod spec semantics be usable for saying what it's pod level object. We can modify the kubelet DRA APIs, what it can return saying what this is a pod level attachment, and we can say what, like, yes, this is something related to the network, and we can do modification in the CRI to pass it down so it finally reaches the CNI protocol.
Right.
That we for sure can do.
Yeah. So talking about this pod network attachments, if you think that there is, if you feel that you want to somehow map it to DRA, I guess something would be possible, but ultimately we would still need, for the scheduling purposes, the normal resource claim object. So if you have a controller that sees a pod network attachment with certain fields and then creates a resource claim, that may be okay. We also need to teach certain components like the scheduler and kubelets who currently iterate over the pod spec resource claims slice to list. Well, containers is the other part, the two parts really. We are already at the pod level, so don't mistake that. We are already at the pod. Currently, DRA is a pod level resource. It just happens to be only be used for containers. So if you define a pod at the pod level, you define a resource reference, and then the containers reference that reference. It's a two-step referencing thing. So you can have some containers using the resource and others don't. That's why we have this two-step reference level. I think that would be possible. Basically, you would have to iterate over two things now. The scheduler would need to know that a pod has a reference to a resource claim if either it's listed in the current field, which is pod spec resource claims, or there is a pod network attachment with certain fields inside, and then deduce from those what the resource claim is. So, I think that would be possible.
So because my goal would be to make pod network front and center, all right, and basically some additional network specific components, like for example this primary piece, right, to be there. I don't want to hide it somewhere behind the DRA APIs. I don't want to do that, right? So basically, I still want to have the pod network API as a front center representation of the network object, of the networking inside the Kubernetes cluster. And then I would prefer to have this field from the usability point of view, rather than having the DRA APIs here and use them and hammer them into the DRA APIs. That's where
if that is your pod network attachment, what would be done with that information regarding DRA? How would you map that information to a resource claim?
Let me think. So basically, this points to this object. Let me show you an example of what object. This is the object that it will reference to, right? So here I have a network, and it can additionally have some custom parameters, right? It informs additional stuff like IPAM and other stuff that we need to know. This can point to who's doing and handling the specific pod network. And then DRA, yeah, that will be tricky because you have what you need is out of this, you need a resource claim. Is that true? Is that understanding that correctly?
We need a resource claim because resource claim tracks the allocation state.
And it would be per our attachment. Is that correct, Patrick? So each attachment.
It would be basically,
it looks like you're replicating what we have with driver and like a class and a claim part, but just to call it pod network and pod network attachment.
And we have to have that, Alexander. We don't want to reference full, so that it has to be a pod network. That's the whole key of this whole effort, Alexander, to have a centralized representation of a network. We cannot go with some custom name or something else for that.
So the analogy I've got in my head is that with DRA at the moment, you have the resource claims, which are kind of pod level. They're an array and a peer of containers that say these are the resources that this pod's going to have. And then in each container, it says there's a field which says this is the resources that are actually attached to this particular container. It feels like the most natural thing to do is just keep that structure so that you have resource claims at the pod level as now, and some containers can reference them, but you can also have a reference in the pod network attachments.
Yeah, that's I think what we're trying to do. We can say that this claim is going to be used as a pod level resource.
And that would be an optional field, so you don't have to have DRA if you're using something more simple. But it does mean that any given pod can specify some parameters based for its network or parameters based for that specific pod, and it's all down to the implementation to deal with all of that.
Then we would have to that will be then orthogonal to what we are doing, or parallel to that. So that's my problem with that, right? Because even for, let's say, I reference what I would. So this is something that Alexander mentioned with the kubelet. That's which I did like, where I want to reference my network here, and then I have an option for my network to have this additional plugin to do something for that network before it's being passed to the CNI. Right, I would like to have that capability, right, because that enhances what we are doing here. right? Gives us if the array understands this piece, right? As is, right?
What about maybe, well, compromise might be a wrong word, but just idea, like brain dump from my side. So like you can have a pod spec level, like your own fields about like network or whatever you call it, doesn't really matter. But you can point, like you can use like the source reference and then point to claim, like to generic object. So vendor specific parameters will be part of the claim object. And everything what is required fields for you, like, I don't know, like if you want to have like IPAM or some service related fields to be always present in the pod spec, it will be part of your struct, but the rest, like the vendor specific, will be just referencing the claim object.
This is something where I'm missing. Let me see, did that load it? That did load it.
So look, what you have right now.
Share this stuff. So what you're referencing, so here to kind of remind ourselves on what the DRA is, right? So we have a resource claim. So basically you point to a claim. Maybe I will ask you this. What does a user create? Is this object? Is this what user creates? The resource claim object?
Either directly or indirectly through a resource claim template, yes.
Because you point to a class. So basically
everything on the right side is what like vendor specific parameters.
Sure, that's fine, right? Because
if you jump a bit on the left side, what I'm saying, like see what like we have this fields, resources, claims, and when you have pointer name equal to resource on the left side. So what I'm saying, like you can have like instead of resources, you will have like your pod networks, you will have like all other parameters, and afterwards you will have like claims, and you will point to like vendor specific parameters.
Name, image. So basically only this. Oh, okay.
This,
so
yes, I'm talking about those 3 lines.
The last one. So resource claim name. How is this different? What does this mean exactly? External claim. Oh, okay. I can point to a exact resource claim.
Yes.
Or so what does this mean? Resource. What does this mean?
So here it means that this container is going to be using the resource out of this claim. So in your example, like you can say, I have a pod network for this pod, which will be using the network interface which is provided by this claim.
No, so basically this is the same kind of so this and this is the same kind of story what there is with mounts in the pod, right? You have volumes, you define volumes on the
that's exactly the same concept. Yes,
exactly same analogy.
So this is something that we do not need in pods because I need pod on the pod namespace, and that's it. I don't have
that's why at the end of the presentation, if you go to the multi-network specific slide, which was at the end of the presentation,
this one.
Where we don't have something in the containers, we have something at the pod level, the resource claims for network, and the user doesn't need to mount that into the container. It would be somehow implicit because that particular type of allocation, kubelet and the kubelet plugin or something in the controller status will make it so that this is pod level and not something that gets passed into container runtimes, unless perhaps the specific network implementation needs it, in which case it might be useful to have something that mounts a device into the container runtime or makes the network device available. That depends. But this is where we basically need to have a discussion. If you agree on this rough idea for doing it, then we can talk about specific changes to DRA to make this possible. But if you're starting with saying we want a core V1 network API defined before we even think about how to implement it, I'm a bit concerned that you will not get that accepted into Kubernetes. Have you talked with people if there is a path from that idea to a specific implementation at all? Because we had big trouble getting any changes into the pod spec, and the solution was to have very minimal changes in core V1 and do everything else in our resource API, where we can have more flexibility to change things as we go along. But you seem to start from the other way around. You want to specify a full API first, and then think about how to implement it.
Because
I'm just wondering
in
how
our
what
case, yeah. So let me answer that. So because we are focusing on the implementation side of the network itself, which maybe other way. Sorry, I said it differently. That part of implementation of the API is done by the vendor, so we don't have to. So we don't care about that. We really want to represent a network, because we cannot implement in Kubernetes all the networks. So that's why the API, as you saw the API from our side, you saw, and basically my API, as you both said, Alexander and Patrick, you both said, our stuff is similar. We don't have the class, we have a provider, which is optional, and we have a parameters reference for the customer to provide their own stuff. Exactly the same thing.
But what is your thinking then? How a vendor implements scheduling, for example?
No, that part is on us. This is where a vendor doesn't implement. We wanted to provide them with the means on how you can expose availability of the specific network. And now I don't have to figure it out, because you already provide that through the array. I can just leverage you to create my own. I can create a core provided controller that will kind of provide capability to specify and give some APIs for the implementers to indirectly say, okay, where the specific network is available, which then be tweaked through the array into the scheduler. So I have that. You covered that for me. So I'm already covered on that one. I was thinking of completely some other elaborated things where a node will have some fields to provide whether the network is up and down. Now I don't have to do that. I have a controller through the array, and I already covered that. So that part already, you covered that part for me. That was my idea was slightly different. And now my thinking is to, and probably most of folks here, to leverage you. The only thing here is the kind of the APIs on how to kind of deal with that one. And then the kubelet side even is better, because now you're enhancing what we are proposing, because now I can have additional DRA plugin ability to do some additional preemptive stuff or before I even do something on my network. So that's even better. So the only thing is right now, when you think about the APIs, our goal was to create the and specify all the generic stuff that are not implementation specific. So scheduler, definition of the network in the pod, and I can going back to the kind of to my cap and let me share this stuff. And if you look at here, right now we have the resource definition itself, and then default pod network, because we have to have backward compatibility attaching to the pod network. I think that would be, most of it that we want to cover in this phase. So that would mean we don't, and in this phase, we didn't want to touch, as I mentioned on the very beginning, we will not get into the array, because keep in mind, as you yourself said, this is a big engagement, and we know that, and I'm aware of that. We are just, you see, just this this discussion took us another hour. It's already take us a month to kind of discuss just this piece. So that's why I don't want to blow up the scope, because I'm pushing back on everything as much as can, because it's bloating the scope. Right now we are, you landed on the right point, because we are talking about the attachment to the pod, about this spec. So this is where the array, we need to kind of discuss on how we do that and how we marry all those two things, right? I want to make sure that that pod network is still front and center. I don't want to hide it behind something, because we have to have pod network, as I said, referenceable through all the other objects. So that part has to happen. Okay.
Masay,
mhm.
if you return to the example what Patrick was trying to prepare.
Oh, apologies. Yeah, let me fix that. Yeah, go ahead.
So like in this particular example, we have like many of the things implicit. So the resource claims are referenced to the pod, and when the driver, like the vendor part, says what this claim is actually something what is network related.
Mhm.
My understanding with all of what you're describing is what like you don't to have implicit things. You want to have explicit field in the pod spec what it says. Like this is the network, and you have like few of fields which is like always must be present regardless of implementation.
True. Yeah.
Well, that's fine. So like it means like you need to have an explicit declaration of usage of things. But what I was trying to say is what like the rest we can do the same thing what like what Patrick showed in this example. Like all the vendor specific parameters can be hidden as a claim. So like your object instead of like you can have a reference which says like the rest of the parameters in this claim, and there's a vendor specific, like I don't really care about. It's vendor part which will figure out what to do with one.
Yeah, I think what Maciej was saying is that if we start with a pod spec that looks like he showed before with a pod network attachment, can we somehow use that as the starting point and not have resource claims with an entry for network?
That will be my ideal kind of.
Yeah,
so that we.
It depends. So, if you can take that information and map it directly to a resource claim. The provider field, for example, could become your resource class name. The parameter reference that you have can be directly become the resource claim parameters ref.
Yeah.
So
if that works, I think if we can make that mapping work, then it's probably not too much work to say that, yeah, if there is only the pod network attachment in a pod spec, then this is a stand-in or a proxy for a resource claim.
So what can always happen? The pod network, the pod network, we can extend it and add the driver name into the pod network then. And
or we can just make it a convention. It could be just for the provider.
Yeah.
Or it could be the name of a class. You basically, the provider defines his names, and a provider that uses DRA, or well, we kind of if they use the entry implementation of this API, they kind of would have to have a DRA driver because that's the expectation.
So yeah, so the driver can either be in the parameter. So we have to do custom stuff anyway. So basically no, we don't want to pull the custom stuff in core code. So that cannot happen. So basically a driver name, a provider is one thing, and it's slightly different to what a driver name would be. But we could have a driver name that will point out to something if you want to use because I assume the driver name is the plugin name that we want to use. Is that correct?
So
yeah, the driver name is ultimately the actual implementation from some vendor.
Yeah,
and
this points to whatever. Calico.
This points to the controller, or this points to the plugin in Kubelet, or both?
Both.
Okay, both.
So for the scheduler, they are, or actually it's the other way around. The scheduler doesn't care. They just create the resource claim, and then the driver need to look at the resource class and the resource claim to figure out whether that is a resource claim that they are responsible for. So if the driver, the different controllers look at that driver name field to figure out that they need to act on something using that resource class.
I think, Pete, you want to say something?
Yeah, so I think actually I misunderstood something earlier, but just want to double check. So the resource claim for a given pod, that is specific to that pod. I mean, you can reuse it obviously for multiple pods, but it would be pod specific configuration for the network is my way of thinking.
It depends. So in this example here, the resource claim name is one resource claim. All pods referencing it get the same instance, the same hardware instance. If you want per pod resources, you need to use a resource claim template. And that template then gets
Well-
turned into a per pod resource claim where every pod gets its own resources.
It would be different.
So-
It would be different configuration in each of those resource claims for each pod, though. So the particular example I can think of is when you're on a network and you have different parameters you want to provide to the network for different
Yeah.
pods. So in that case, you'd have a different resource claim. You know, you have a big fat network interface claim and a small low capacity network interface claim for potentially for the same network.
So I think that this picture is so basically the analogy here, Patrick, is slightly different. Our pod network is the template.
It's a
the resource
template and it
claim-
has parameters, yes. And then a controller
And
that takes that as input creates a resource claim template. It creates the parameters,
Yeah.
and the rest
Yeah,
is
and
pure
this is something-
DRA.
This
Yes.
is something that I wanted to kind of introduce into, because that part is the same what I was thinking, maybe because I didn't get to that. Right now I wanted to keep it simple and only use the template. Right, you see my pod attachment has only point to a network, which is the template, and then I don't have any per attachment configuration specified here. The only thing that what I would think, at least for networking, is that a resource claim, so this pair attachment thing cannot be shared. I cannot attach the same network to the same interface with the same parameters to two pods. That should not be possible. Let's say, because in our case, it can contain things like, let's say, MAC address, IP address. If that's the case, you cannot connect into two pods. Alexander, and let's call it, because I think we are over time.
Yeah.
Alexander, go ahead.
Well, we think what we designed a DRA to be for is to have like vendor flexible to expose whatever you want. So like if you think about like putting MAC address, yeah, it might be not working, or like you might want to have a chain of parameters to be when you're requesting something per particular pod. But the idea was what like you can create one claim which says, I want like this claim is like private VLAN 22. And this VLAN is provisioned across like multiple racks in your cluster. And when you can say like all the pods refer to this VLAN 22. Like that's one representation. Second representation is you can say like I want to have like the pods which has like each has unique MAC address generated, and like VLAN it will be just one of the parameters. So like the whole VLAN management will be hidden in your controller and your like driver parts, like not visible to the owner. So like we try to make the DRA as flexible as possible to cover all possible scenarios what we come up with devices, and we hope what it should be reusable for network.
Yeah. All right, folks, let's end it here. We are way over. Let's try to.
Is it worth anybody writing anything up from this? Sorry, Matthew, maybe it's what you're about to say. I feel we've talked. Yeah, we've talked about a lot of things, and I'm wondering if it would be worth trying to write down what the different options are.
I will try to come up with that. Yes.
I think that'd be very good if you could. Thanks, because then we can look at it and we can.
Yeah, I will.
It'll hopefully make it more concrete.
Yeah. All right. And yeah, let's. Hopefully we can come up. This is good because this fits into like the area that we are currently at, the kind of how we attach. Because I think what it boils down to right now is how do we kind of design the API so they fit with DRA on the pod level, right? Because this is where we exactly are at, and we need to discuss and walk through. Okay, so let me think about it. Let me capture all the discussion from the recording, and then let's try to finalize this next week. Hopefully, I said that last week, but we'll see. All right, thanks everyone. Hear from you next week.
Thank you.
Thanks, Phil. Bye now.